On June 23, 2026, Parasagenetics issued a request to hybrid creators worldwide to create beasts capable of freeing an abandoned facility from the dominion of the horrifying Terrata scorpions. We here at Galactic Genetics have answered the call and are eager to unveil a truly horrifying creature of our own for this operation, a true executioner of the Terrata scorpions. Starting with the base of the hybrid, we are going with one of the mightiest apex predators of the Triassic, Saurosuchus. This heavily built ancient crocodilian had a robust frame and upright legs to serve as a promising base for an efficient killer. Despite its robustness, Saurosuchus could still rear up on its hind legs, allowing the hybrid to be able to more easily navigate rugged landscapes as well as improving this hybrid's ability to wrestle and swipe at opponents. In order to avoid accidentally exceeding the weight limit, we are using the DNA of one of the smaller adult specimens. The next contributor is another formidable ancient crocodilian, though this time it hails from the Cretaceous. Saurosuchus is added for its skull structure, housing several fang-like xiphodont teeth for slicing flesh. Despite this, Saurosuchus still had an incredible bite force of almost 3,100 newtons at 113 kilograms. This will give our hybrid a truly terrifying bite force when scaled up. Next up is a much larger Cretaceous predator in the form of Daspletosaurus. This theropod augments the eyes and the back of the skull in order to provide the hybrid with a greater degree of binocular vision for much better depth perception. It also provides its pneumatic bones and air sacs for weight reduction, buoyancy, cooling, and better oxygen intake. Finally, we will take some of the size of Daspletosaurus, just enough to ensure the final hybrid is as close to 1 ton as possible. Returning to the realm of ancient crocodilians, next up is the Coprosuchus. This animal will provide its incredibly long knife-like fangs for piercing deep into prey. Despite their appearance, these teeth were remarkably sturdy and capable of even biting into bone. Coprosuchus also provides fused nasal bones for greater bite force tolerance, further safeguarding the teeth from fracture. Finally, Coprosuchus provides its much longer retroarticular process, which serves as an anchor point for muscles, allowing the jaw to open much wider and much faster. Moving on to a modern predator, we have the Kodiak brown bear. This specific bear is being used for its robust forelimbs, which will aid the hybrid in grappling with opponents as well as delivering devastating swipes. The bear also gives us its shoulder hump for further arm and shoulder muscle attachments. The bear's sense of smell is incredibly advanced and will be added to assist in detecting threats in pitch-black environments. Brown bears are also surprisingly intelligent with problem-solving skills on par with great apes. This intelligence increase from the bear will allow the hybrid to devise strategies to more easily lure opponents to it, as well as preventing it from being outsmarted by the Terrata scorpions. We will also take the bear's subcutaneous fat layer, which can be anywhere from 2 to 4 inches thick to serve as a form of armor. While it is possible for this fat layer to be thicker, it is unlikely that the hybrid will meet that level of caloric consumption, keeping the hybrid within the weight limit. Finally, we will take the bear's tooth enamel. The enamel of mammals is much thicker than that of reptiles and includes several crystalline structures that increase strength. Adding this stronger enamel further increases the durability of the fangs to prevent them from snapping. Tethys hadros is used to provide its hip, hind limbs, and tail. This will further improve the hybrid's ability to rear up on its hind legs while also drastically increasing the speed of the hybrid, allowing it to keep up with the Terrata scorpions. Unlike other hadrosaurs, Tethys hadros still retain the flexible tail, which will come into play later in the genome. Next up is the black-crowned night heron, which improves the nocturnal vision of the hybrid as well as turning the eyes a blood-red color. This bird also provides its mitochondria. Bird mitochondria are special as they produce much more ATP than mammal or reptile mitochondria, increasing how much energy the hybrid has. Most importantly, the night heron provides unihemispheric sleep, allowing the hybrid to rest one half of the brain at a time while keeping the other half awake. This will make it so that it is impossible to sneak up on this hybrid, even while it is sleeping. While the night heron has great nocturnal vision, its eyes are sensitive to bright light. Therefore, the next contributor is the polar bear. The polar bear has special nictitating membranes that can filter out the bright glare of snow, thus allowing the hybrid to see well in more well-lit conditions. These membranes also improve the hybrid's vision underwater. The polar bear also replaces the relatively blunt claws of the Kodiak bear with more sharp and curved claws, improving this hybrid's ability to deal devastating damage with paw swipes. Next is the Cuvier's dwarf caiman. This tiny crocodilian is arguably the most important contributor in this hybrid. Firstly, it provides full-body osteoderms with thick bony scutes on the back, stomach, tail, flanks, and even the eyelids. Pliable sutures between the osteoderms allow the hybrid to retain flexibility and agility in spite of the armor. These osteoderms are vascularized to allow for better thermoregulation. Faster blood clotting also allows the hybrid to more easily recover from damage. Crocodilians can also seal their ears and nose when needed, which will be used to allow the hybrid to block bad smells or loud sounds. We will also take the four-chambered heart of the caiman, which has a specialized mechanism to shunt carbon dioxide-rich blood to the stomach to help produce stomach acid. This mechanism allows the hybrid to quickly remove CO2 from the bloodstream and allow it to live in CO2-rich environments. Finally, we will take the integumentary sensory organs on the skin that allow crocodilians to sense vibration in the water, allowing the hybrid to detect opponents in flooded areas. Next is the largest lizard currently alive in the form of the Komodo dragon. This giant monitor lizard provides iron coating on the enamel as a final durability increase to the long fangs of the Coprosuchus. The Komodo dragon also reinforces the polar bear claws with beta-carotene for added strength. Komodo also provides venom glands to make the saliva of the hybrid venomous. Finally, the Komodo dragon provides its strong immune system and venom resistance. Moving on to a smaller venomous lizard. Next up is the Gila monster. This lizard provides much more extensive osteoderms on the head and face, protecting the hybrid's snout from the quills of the Terrata scorpions. Gila monster also makes all the osteoderms more durable by coating them with a layer of enamel-like osteodermin, making the already incredibly strong caiman osteoderms even more resistant to damage. Finally, the Gila monster replaces the Komodo dragon's venom with its own. As the Terrata scorpions have Komodo dragon in their genome, trying to use Komodo venom against them would be foolish. The venom of the Gila monster is far more effective here, causing intense burning pain in opponents, making the bite of this hybrid even more dangerous. To build on the Gila monster venom, we also have the Waggler's pit viper. Unlike its more well-known cousins like rattlesnakes and the fer-de-lance, this pit viper species relies on wagglerins, unique neurotoxic proteins that rapidly paralyze prey. Even with golden poison dart frog and tiger shark, the Terrata scorpions lack proper resistance to wagglerins. This means that the hybrid would be able to quickly paralyze opponents after only one or two good bites, the tusks ensuring the saliva penetrates deep enough. In addition to the venom, we will also take the heat-sensing pit organs common to all pit vipers, allowing the hybrid to sense the thermal signatures of opponents even in pitch darkness. Next is the Stegosaurus, which will first provide its cooler armor. This mesh of osteoderms on the throat will protect the hybrid's neck from the formidable claws of the Terrata scorpions. But primarily, this dinosaur will provide its iconic thagomizer. Due to the fact that the Tethys tail is flexible, the thagomizer will have a surprisingly wide range of motion in spite of being mounted on a hadrosaur tail. This means that if any Terrata scorpions tries to flank the hybrid, it will get struck by 4 solid bone spikes capable of drilling through osteoderm, bone, and anything in their way, instantly crippling them. Next is a rather unimpressive looking snake, the Mushurana. What makes this snake special is the fact that it is completely immune to the venom of the fur ants which it eats. This, coupled with the Komodo dragon immune system, will make the hybrid completely immune to the venom of the Teratoscorpions. Also, due to the fact the Mushurana belongs to the colubrid family of snakes, it can emit a foul-smelling musk to make it smell and taste atrocious, deterring potential threats. Our second to last contributor is the blue wildebeest. This animal is going to provide its unique muscle fibers that are more efficient and thus produce less heat, preventing the hybrid from overheating. The carotid root will also be added to cool blood heading to the brain. We will also be taking the keratinized tongue and papillae in the mouth to protect the hybrid's mouth from the quills of the Teratoscorpions. Finally, we will be taking the horns to serve as intimidation and as a way to stab into taller opponents. Our final contributor is the European starling. This bird is being used for one ability only, its incredible vocal mimicry. We will take its vocal abilities to allow the hybrid to be able to mimic a wide variety of sounds. Unlike the lyra bird, the starling has a greater tendency to use its mimicry for defense rather than mating. This will allow the hybrid to blend in with the Teratoscorpions from a distance by mimicking their vocalizations or intimidate them by mimicking sounds like gunfire or a dying Teratoscorpion. These contributors combine to form a truly horrifying creature, one which never truly rests and stalks prey in the dark. Calatif Genetics is proud to present Carnifex ferox, the cruel butcher crocodile. Codename, Todd the Butcher. This hybrid is 20.3 feet long, 5.74 feet tall at the hip, weighs 2,000 pounds, runs at up to 14 miles per hour, and has a bite force of 12,500 newtons. Comparing Todd to a Teratoscorpion, we can see that they are similar in body length and overall size, granting them similar maneuverability. Both hybrids have ornithopod-derived leg muscles, granting them similar speed. However, Todd is more robust and slightly heavier, as well as having a more stable quadrupedal stance. This gives Todd an edge in battle as he has better balance and can access the throat and underbelly of his opponent much easier. Meanwhile, bites from the Teratoscorpions must come from above, where the caiman osteoderms are thickest, with its long and incredibly durable fangs, venomous bite, powerful forelimbs, sharp horns, and thagomizer. Todd is capable of easily dealing fatal damage to a Teratoscorpion. Meanwhile, the thick subcutaneous fat layer, full-body osteoderms, and venom immunity provide enough defense to shrug off any damage dealt by a Teratoscorpion. In regards to the different environments this hybrid will be deployed in, Todd's sensors generally allow him to detect opponents easily in low-light conditions. The carbon dioxide disposal from the caiman allows Todd to handle the toxic gases present in the lab area. In the residential area, Todd's sense of smell and heat sensing allow him to detect any nearby Teratoscorpions, while vocal mimicry allows Todd to either blend in with or intimidate the Teratoscorpions. In the botanical research area, Todd will be capable of navigating through any rough terrain due to his facultative bipedalism, allowing him to be far more terrain compatible. In addition, if Todd enters the water, his skin sensory organs from the caiman allow him to detect any Teratoscorpions near him, while his bare forelimbs make him a surprisingly capable swimmer when coupled with the fat layer and pneumatic bones providing buoyancy. Todd is currently being transported to the staging ground via armored convoy. We wish Parasagenetics luck in eradicating the Teratoscorpion menace, and we hope he finds our contribution up to standard.